heat transfer. Heat transfer. Yeah, today we will discuss about the heat transfer. First of all, what is heat? Heat is a form of energy. Heat is a form of energy which is transferred by virtue of temperature difference. Which is transferred by virtue of temperature difference. That means, according to first law of thermodynamics, heat and work are mutually convertible. But here we are not going to discuss with work transfer. In our heat transfer, that is in the third year, second semester, we are going to discuss only with heat transfer only. Yes. Then coming to the second law of thermodynamics. Second law of thermodynamics. What are the second law of thermodynamics? This second law of thermodynamics deals with two statements. Which deals with two statements. Okay, what are the two statements? We will discuss. First one is the Kelvin. First one is the Kelvin Planck statement and other is the Clausius statement. Now, in our heat transfer, we are going to deal with only one statement, that is called Clausius statement. Okay, what is this Clausius statement? Clausius statement. What is this Clausius statement? Which states that heat transfer will always take place from a body which is at higher temperature to a body at a lower temperature without any work input. Okay, that is our heat transfer. Clear? That our entire heat transfer deals with the Clausius statement. Clear? That we already studied in our basic thermodynamics. Now we are going to study in detail about the heat transfer. We are going to deal with only heat transfer, not work done. Okay? Then, what are the modes of heat transfer? What are the modes of heat transfer? Yeah. One by one, we will discuss about the modes of heat transfer. As we already studied in intermediate or plus 2, whatever you studied, in that you studied modes of heat transfer. What are the modes of heat transfer? First one, conduction. There are three modes of heat transfer. Conduction heat transfer, then convection heat transfer, then radiation heat transfer. Then radiation heat transfer. These are the main three modes of heat transfers we have. Okay, now we will discuss one by one. What is conduction, what is convection, and what is radiation? These are the three main modes of heat transfers. We will discuss one by one. First, we will go for the first one, that is conduction. Okay, yeah. What is this conduction? Conduction will always take place in the solids. The main predominant in the solids, the heat transfer is due to conduction only. For example, let us take a spoon. Let us take a spoon. Which is made of stainless steel or steel. Then if you heat the spoon at one location, at one point we are going to heat the spoon. Then what happens? Obviously, at place 2 also temperature will be higher. At point 2, at the other end also the temperature will be higher. After some time, this second point, the temperature is also going to increase. How it is going to take place? This is entirely due to motion of free electrons. What is temperature? Temperature is a measure of the velocity of molecules. Velocity of molecules. If the temperature increases, the velocity of molecules increases inside the solid. Inside the solid. Then let us take. If you heat at a particular location, the composition of steel or any solid which consists of molecules or electrons, okay, they collide with each other. While we heat at a particular location, what happens? The velocity of the molecules is going to increase. Then they will collide with each other and distribute evenly to all the surface, all the portion of the metal or solid. Clear? Because of this, the heat is transferred from point 1 to point 2. Okay, this is about the conduction. Then what are the parameters on which this conduction heat transfer depends? On which this conduction heat transfer depends. Okay, we will discuss one by one. Then first one is the thermal conductivity. Thermal conductivity. What is this thermal conductivity? Which is denoted by generally K. Which is denoted by K. What is this thermal conductivity? It is the ability of a material to conduct the heat through it. To conduct the heat through it. Okay. K is there. If the value of K increases, if the value of K increases, then what happens? Then conduction heat transfer rate will increase. Then conduction rate heat transfer rate will increase. Then what about the other parameters on which conduction heat transfer depends? It depends upon the area of the surface directly proportional to the area of the surface. If the area increases, obviously heat transfer rate will increase. That is why in many cases we are going to increase the area of exposure to the environment. For example, fins. In IC engines, we will use the fins for cylinders. Clear? That means what we are going to we are going to do the increase the rate of area of exposure to the environment. That is why we are going to increase the conduction heat transfer with fins. Yeah. Next, what is the other parameter? What are the remaining parameters? Then let us take the main important parameter. We already discussed about the Clausius statement. Heat transfer will always take place from higher temperature to lower temperature. That is the main potential which is responsible for the heat transfer is temperature difference. That is delta T. Q will depend on delta T also. That means now we can make one equation based on these parameters. Yeah. Now, what is this? Q is equal Ka into dt by dx. Dx is the thickness or length. Okay. Now, Q is equal to minus Ka into dt by dx. Or generally simply Ka into delta. Ka into delta T also we will define. Okay. Now, see here. Q is directly proportional to K, Q is directly proportional to area, Q is directly proportional to delta. Clear? Now, what is this law called? This equation is called Fourier's law of conduction. Fourier's law of conduction equation. This equation is called Fourier's law of heat conduction equation. Because the scientist Fourier, Scientist Dr. Fourier derived this equation, hence the name is given Fourier's law of heat conduction. Clear? This is about the conduction heat transfer. Okay, now that is why we have to choose while designing any surfaces. Let us take a wall. If you want to design a wall, first of all, you must have the knowledge of what is the thermal conductivity of the material we are going to choose. Clear? Then what are the main applications of heat transfer? Where we are going to apply the heat transfer? In all the fields we are going to apply the heat transfer. What are the fields we are going to apply? We will discuss some examples. Let us take any auditorium building is there. for auditorium building, if you want to construct a wall, then based on the heating load or cooling load, whatever the load present inside the auditorium or some room or space to be which is to be cooled or heated, based on the heating load or cooling load, we have to design the wall material. Okay, if we want insulation, then we have to go for low thermal conductivity materials. If you want high heat transfer, then obviously we have to go for high thermal conductivity materials. Based on that only we are going to design. Then what are the other applications? In all fields like hospitals, refrigeration and air conditioning systems, defense industries, aircraft applications, like that different fields are there. In all the places we will use the heat transfer. Even in our automobile industry, IC engines, all this depends upon our this heat transfer only. Yeah. Okay. Now we will go for the next mode of heat transfer. What is the next second one? Second mode of heat transfer is convection. This second one is the convection. What is this convection? Convection. Let us take a metal or solid is there, or you take a pipe, steel pipe. Let us take a steel pipe. Inside some fluid is flowing. Let us take a steel pipe. Inside a metal or a steam is flowing inside the tube. Steam is flowing inside the tube. Then here the mode of heat transfer, see, observe, in solids only due to inside molecules of the one material, that is the solids. Whereas here two substances are there. One is the metal is there, anyhow there is metal, that is cylinder vessel is there already. Then steam is there. What is this steam? What is this steam? Now we will discuss. Fluid. What is this fluid? First of all, what is fluid? Fluid means that may be either liquid or gas. Liquid or gas. Here steam is there. This is one fluid. Or water is there. Hot water is flowing inside the tube. Liquid water is flowing inside the tube. Here not only conduction, because of not only conduction heat transfer, one more heat transfer is there. That is called convection. This convection heat transfer is accompanied with along with conduction, and one more is there, that is called conduction plus convection. Okay, now see here, now we can easily define convection. What is this convection? The heat transfer takes place always in the presence of the fluid medium, then that is called convection heat transfer. Then that is called convection heat transfer. Clear? That means in the presence of fluid medium, if there is any heat transfer, then that is called convection heat transfer. Clear? Now, let us take a liquid water or steam which is flowing inside the tube, stainless tube or some other solid. Then, see here, anyhow, inside the tube, stainless tube material, inside the tube there is conduction. Then between the metal and liquid water, what is the mode of heat transfer? Inside the metal we already discussed, that is completely due to conduction heat transfer. Now here one more fluid is there. One fluid is there. Because of this fluid, heat transfer from fluid to steel will take place. This is called convection heat transfer. Conduction plus convection, that is convection heat transfer. Now, that means the main important parameter in this case in the convection is in the presence of the fluid medium. In the presence of the fluid medium. Now, what is the governing equation for this convection heat transfer? We will discuss. Yeah. Q, anyhow, Q is directly proportional to area, that is universal. Q is directly proportional to the area. Then obviously delta T, temperature difference is the main important parameter which is the main responsible for the heat transfer. Now we will discuss what is this. If you remove the proportionality constant, Q is equal to, instead of K as in solids, here one more term is there, that is called heat transfer coefficient. Heat transfer coefficient, that is Q is equal to HA into delta T. HA into delta T. This is the main important parameter. Heat transfer coefficient. That heat transfer coefficient H, we are not having any control over this. Okay, now let us take atmosphere is there. The H value of atmosphere is constant. We are not on atmosphere, we cannot have the control. Okay, H. If the H value increases, but depending upon the fluids, the H value will change. Clear? But atmospheric air we cannot have any control. Clear? Q is equal to HA into delta T. Clear? Now, what is the H? Unit of H. H is equal to now Q by A into delta T. That means Q is already there, joules per second or watt. Rate of heat transfer Q is watt per meter square Kelvin. Watt per meter square Kelvin. This is the unit for heat transfer coefficient H. Then what about the thermal conductivity? For K it is watt per meter Kelvin. Watt per meter degree Kelvin. That's it. Now, this is about the second mode of heat transfer. Okay. Now we will go for the last one, that is third one. What is that? That is radiation heat transfer. Radiation. What is this radiation? Radiation. Nowadays we have radiation. We are discussing about the radiation is there. What is radiation? The heat transfer from one body to another body without the presence of any material medium in between them. There is no direct contact. Still there is heat transfer. Okay? What are the examples of radiation? Once again, radiation. What is radiation? Heat transfer from one body to another body without the presence of any material medium in between them. It is called radiation. Clear? Now, what is this radiation? Okay, we will discuss. On what parameter the radiation heat transfer is going to depend? Obviously, temperature Q is equal to directly proportional to area. Then Q is also directly proportional to fourth power of its absolute temperature. Radiation heat transfer is directly proportional to the fourth power of its absolute temperature, that is T power 4. If you remove the proportionality constant, then what is the constant we have to put? Then Q is equal to sigma A into T power 4. Sigma A into T power 4. This is the constant in place of proportionality. Clear? Q is equal to sigma A into T power 4. What is this sigma again? We will discuss once again what is this sigma. Sigma, it is given by some scientist, the constant, Stefan Boltzmann constant. What is this Stefan Boltzmann constant? The scientist Stefan Boltzmann constant discovered this radiation heat transfer. Hence, he put his name on behalf of the scientist Dr. Stefan Boltzmann. Constant is given, that is nothing but Stefan Boltzmann constant. Stefan Boltzmann constant. What is this Stefan Boltzmann constant? Then, what is the value of Stefan Boltzmann constant? Okay, we will say Stefan Boltzmann constant 5.667 into 10 power minus 8 watt per meter Kelvin power 4. This is the Stefan Boltzmann constant. 5.667 into 10 power minus 8 watt per meter square Kelvin power 4. That is about Stefan Boltzmann constant. Yeah. In our laboratory also we are going to do many experiments on conductivity, thermal conductivity of metal rod, that is we are going to determine the thermal conductivity of the metal rod. Then in convection, yeah. In convection also we have convection. In the convection again, we have two types. One is natural convection, other is forced convection. Forced convection. What is this natural convection? What is this forced convection? In the natural convection, or it is also called free convection. Natural convection or free convection. If the heat transfer takes place due to temperature difference or density differences, or due to buoyancy effect, then that is called natural or free convection. Natural or free convection. What is this natural or free convection? Now, for example, where we have to use this natural convection, where we have to use for forced convection. Yeah. Now we will discuss about the forced convection. What is this forced convection? Forced convection. This forced convection deals with the convection heat transfer takes place with some external agency or some with external power. Let us take a blower or fan, or instead of if you are dealing with liquids, then pump, water pump. Okay, pump. Then to drive the pump, some work input is required, or to drive the fan, some work input is required. That means artificial energy is required. Artificial energy is required. Clear? That means by using some external agency, if the heat transfer takes place, then that is called forced convection. Then, okay, well and good. When we have to use the natural convection, when we have to go for the forced convection. Okay. If the system condition fulfills with natural convection, let us check our two-wheeler. Two-wheeler is generally made with IC engine. That means motorbikes, IC engine. They will use air cooling system. Okay, now stationary. If you go for stationary two-stroke engine, there will not be any water cooling system. That means there is no pressurized or forced convection. That size is limited. Okay, now